Bismillahirrahmanirrahim. Assalamu alaikum dear students. I am Muzammil Yaqub, lecturer Department of Technology and your instructor for this course, which is Computer Aided Building Modeling and Design. Dear students, in our today's video lecture, which is 11th lab lecture, we are going to discuss about working with 3D or 3-dimension AutoCAD and working with coordinate systems, right? So we will discuss about different coordinate systems. So let's start our lecture. So first of all, what is 3D? In 3-dimension drawings, you work with z-axis in addition to the x and y-axis. Over here in this picture, you can see there are 3 axes shown in these pictures. This one is known as z-axis and the other 2 are called x-axis and y-axis. So plan view sections and elevation represent only 2 dimensions, and isometric and perspective drawings on the other hand represent all 3 dimensions. So by default, AutoCAD stores the z value as your current evaluation with the thickness of 0. So this was all about 3-dimension or 3D. Now let's discuss the drawing objectives or objects in 3D, providing the 3 majority advantages. So the first and main advantage is that once you draw and then can be viewed and plotted from any angle, I mean it is known as or called viewpoint, then a 3D object hold mathematical information that can be used in engineering analysis, I mean structure analysis for steel designing, such as finite element analysis and computer, numerical control. In short, you can see CNC. And the last one is shading and rendering, enhancing the visualization of an object. So these are the 3 main objectives or advantages, positive advantages or positive objectives of the 3D. So let's discuss some frequently used 3D terms as well. So 3D object made in CAD is known as model, or when you hear the word models, so you can clearly think is that it is made in 3D, right, or it is a 3D object. And 2D work referred to as drawing or drafting. So the difference is quite clear between the model and drafting. Now comes wireframe model. So in this model, object by or its edges only, wireframe cannot hide object that are behind them. So whole has no meaning in the wireframe model because there is nothing in which to make a hole. So there is all about wireframe model. Now surface model. Surface model means in other words or in short, we can say solid plus empty shell, right? Surface model often use wireframe models as a frame for their surfaces, and surface model means part wireframe plus part surface. So by combining these two, it gives us surface model. Then comes solid model. So wireframe, surface model and computer calculated masses, for example volume, center of gravity, mass, moment of inertia. And solid model looks like wireframe unless a hidden line remove command is in effect. And the last one is it is important point known as rendering. So shaded and realistic looking picture of a surface solid model is called rendering, and or in other words you can say grayscale rendering, or fully capable of coloring rendering you can say. So in this picture there are 3 examples given, you can see. So the first one over here is made in the or drawn by wireframe method. The second one is drawn by surface method, and the last one is drawn by solid method. So the difference is quite clear as we discussed in our theories in the previous slides. Now discuss coordinate system. So CAD provide us, or AutoCAD provide us, two type of coordinate system. You can know the one is known as WCS or World Coordinate System, and another one is known as UCS or User Coordinate System. So basically WCS is a fixed and cannot be changed in this system. When viewing the origin from 0, 0, 1, the axis start at the point right 000 and value increase as the point moves to the operator's right. The y-axis starts at 000 and value increase as the point moves to the top of the screen, and finally the z-axis start at 0.0 and values get larger as it comes toward the user. So basically in 2 dimension world coordinate system is used, right? The next is user coordinate system or UCS. It allows you to change the location and orientation of x, y and z axis. The UCS command let you to redefine the origin of your drawing and establish the positive x and positive y axis. So let's discuss some points about setting the display of a UCS icon. So the UCS icon provides a visual reminder of how the UCS axes are oriented, where the current UCS is origin is, and the viewing direction relative to the UCS XY plane. So AutoCAD provides 2 methods of displaying icons. The first is 2-dimension UCS style or 2D style, and the second is 3-dimension UCS style or 3D style, and displays different coordinate system icons in paper space or in model. Or here in this picture you can see the UCS icon for model space and UCS icon for paper space, and the last one is UCS icons with grips. Now defining new UCS. So the UCS command lets you to redefine the origin by any of the following 5 methods, right? So over here in this picture you can see one of the method. By this method we can just click on the desired origin or desired axis origin, so you can set up according to your requirement. And another method is specify a data point for an origin, then specify a new XY plane by providing the 3 data points, or provide a direction for Z-axis, or define origin relative to the orientation of an existing object, right? Or in the important, mostly people use this approach by defining an origin by selecting a face, right? Then the fourth one is define an origin by aligning with the current viewing direction, and the last one is define an origin by rotating the current UCS around one of its axis. Then comes viewing in 3D. So you can view a drawing from any viewpoint in a model space. For example, the direction from which you view your drawing or model is called viewpoint. Then comes from your selective viewpoint, you can add objects, modify existing objects, or surpass any hidden lines from the drawing. Available tools includes these two: viewing a model by entering command, just type viewpoint in capital VPOINT, or you can use a second approach which is view cube. So let's discuss view cube tool. I think it's very important and most common and frequently used and very easy approach as well. So the view cube tool is used to control viewing of a model from various points in model space. The view cube tool is 3D navigation tools that is displayed when you are working in a 3D visual style with view cube tool. So you can switch between the standard and isometric views as well. So over here in this picture you can see how view cube tool looks like. So you can dramatically manipulate the viewpoint by placing the cursor on the view cube, holding the pick button down or moving the cursor in the direction you want, and then sense the change with the cursor movement as object in the model are viewed from the changing viewpoint. So place the cursor on the ring with the direction shows, N means north, east, E means east, S means south, and W stand for west. So holding the pick button down and moving the cursor cause the viewpoint to rotate around the origin of a current UCS. So just clicking on the compass direction letters, you can choose the direction as well. So this is how the viewpoint, as I previously slide shown to you, moves, right? So over here the different directions are shown, and the box indicates the different faces of the object. So just selecting the home icon above and to left, the view cube returns the display to the previous view, right? So selecting the one of the arrow near the pointing towards the view cube cause the displays to change the view to the one and that side of the view cube. So you can switch between the coordinates as well. Over here just right between the cube tool option, you can see the two coordinates. WCS means world coordinate system and UCS user coordinate system. So you can switch between these two as well. For example, if you are working on a 2-dimension, WCS, and you want to convert that drawing into 3-dimension, to just click on the UCS, and then it will manage your coordinate system. So this was all about our today's video lecture. Inshallah, in our next video lecture we will discuss about in these things in further details, and will practice on CAD as well. So see you inshallah in our next video lecture. Till then, Allah Hafiz.